Alright, this lesson is about arcs and central angles. This is an arc, alright? An arc is a portion of a circle, like this. A central angle is an angle whose vertex is at the center of the circle. So, when you have a central angle, there is an arc that we say, we call it an intercepted arc. Alright, for example, this orange arc is the arc that is intercepted by this central angle. Now, the measure of an arc is measured in degrees, and the measure of the arc is the same as the central angle. So if the central angle is 50 degrees, then the intercepted arc is a 50-degree arc, and so on. Okay, more vocabulary you need to know. Alright, a minor arc is an arc that is less than 180 degrees. Well, maybe I should skip to a semicircle since everything's being compared to it. A semicircle is an arc that is equal to 180 degrees. Now, you know that the entire circle is 360 degrees. So a semicircle is literally half a circle. Semi meaning half. So 180 degrees is half of a circle. Alright, it's very hard to draw this neatly, but this is a semicircle. It's half the circle. It is 180 degrees. Okay, semicircle. Now, anything less than half the circle is going to be a minor arc. Alright, a semicircle is an arc. It's a 180-degree arc. Anything less than a semicircle is going to be a minor arc. So, you know, if I have an arc like this, okay, that is a minor arc because, you know, a semicircle would be more like all the way to here. So it's less than 180 degrees, that makes it a minor arc. Oh, by the way, let's talk about labeling. So let's say if this arc begins and ends here. So say this is point P and point Q. Alright, we could call this arc PQ by putting a PQ and an arc symbol over the top. So this would be arc PQ, and it is a minor arc. Now, a major arc is an arc that's greater than 180 degrees. Okay, so I could have an arc that went all the way around the circle like this. Okay, it's going, it's still a minor arc. Okay, right about here it hits about the semicircle area. But if I keep going, this is bigger than 180 degrees. Okay, so for example, this is what you would call a major arc. Alright, it begins here, it ends here. So let's say if this point was K and this point is B. Now, to name a major arc, you need at least 3 letters. So I'm going to need a third letter. Like, let's say I have this point here and it is M. So now I know that this is arc KMB. That means it starts at K, it goes through M, it goes all the way around to B. And I had to put the arc symbol over the top. So major arc takes 3 letters to name it. So arc KMB. If I just say arc KB, why can't I just call this arc KB? What do you think? Alright, well maybe you just thought about the fact that if I just say arc KB, well, that would mean the minor arc from K to B. Okay, so this right here would be arc KB. Okay, minor arc. If I want to go the long way around, I have to force it to go the long way around by mentioning a third letter. Okay, now since this is the square for major arcs, I'm going to erase this one. Okay, this is a major arc. And we already talked about a semicircle. Alright, a semicircle, you also need a 3-letter designation. Okay, so let's say this is R. No. let's say this is D, and this is L, and this is B. Okay, so I could name this semicircle arc DLB. Alright, it takes 3 letters to name a semicircle as well. Alright, otherwise, if I just said, everybody, okay, look at arc DB, you wouldn't know if I meant to go around the top or around the bottom. So I have to say DLB so everybody knows to look at the top. Alright, so that's the background knowledge that you need to have to do the lesson. Alright, we're supposed to determine in circle F whether the given arc is a minor arc, major arc, or semicircle. Now, at a glance, without even looking at the picture, we should be able to tell that 2 of these are minor arcs just by the way they're written. I'm talking about number 1 and number 2. Simply the fact that these are written with only 2 letters means that it has to be the minor arc. Okay, so arc AB and arc AE automatically are going to be the minor arcs because there's only 2 letters. Okay, so by definition, if it's only 2 letters, it means the short way around. Now, having said that, that doesn't mean that none of the rest of these are minor arcs. Just because you use 3 letters doesn't mean that it's automatically going to be a major arc or a semicircle. So let's look at arc AB, for example. Alright, because they said AB with 2 letters, it automatically means from A to B the short way. Okay, so that is a minor arc. If they want to say from A to B the long way around, they're going to have to say like AEB or ADB or ACB. By the way, all of those 3 things I just said were the same arc. Okay, what else did they say? Arc AE. Again, arc AE, because they said only 2 letters, it means from A to E the short way. Alright, if they mean to be the long way, they have to mention the 3rd letter in between. So yeah, those are minor arcs. Okay, now what about arc EAC? That means from E to A to C. On the circle, by the way, I've had kids go, okay, from E to A to C, they'll go from like E to A and then like cut through the circle or something. There's no cutting through the interior of the circle. So when we say EAC, what we mean is starting at E, going through A, and arriving at C, staying on the circle the entire time. So E, A, C, like that. So what do you call that? That is a semicircle, alright? Because this is a diameter. So that makes this a semicircle. Alright, what about ACD? ACD. Okay, ACD means from A through C and around to D. That is clearly a major arc. I'm just going to let it be big. I started to make the ink small so I could write more easily, but I'm tired of switching back and forth. Alright, what about CAD? CAD. Okay, CAD means from starting at C and going through A and ending up at D. That is another major arc. Okay, that's bigger than 180 degrees. Right here is a semicircle. Okay, so it went past that, so it's definitely a major arc. Alright, what about DEB? Deb. What about our good friend Deb? DEB. That means start at D, pass through E, and go to B. So D, E, B. What do you say? That is a semicircle. Notice that this is a diameter, so that makes this definitely a semicircle. Okay, what about BAE? Come get it, bae. Come get it, bae. Number 7. My motorcycle. BAE. Alright, so that means we're starting at B and going through A and ending up at E. BAE. Notice, even though it's a 3-letter designation, it is still a minor arc. It is less than 180 degrees. Come get it, bae. I'm going to have that song in my head for the rest of the night. DEC. DEC. Okay, so from D, yeah, again, some kids try to do this somehow. DEC. And they'll cut through the interior of the circle. No, no, can't do that. Alright, DEC. Got to go all the way around, staying on the circle the whole time. And that is clearly a major arc. Major arc. Alrighty then, so that's it for that little section. What's next? In the figure, PR and QS are diameters. Let's see, PR and QS. Alright, so the things that look like diameters really are diameters. That's very helpful. Okay, what else? Find the measure of the indicated arc. So we need the actual measures. So I am going to have to make this smaller so I can work. Alright, we need the measure of PQ first. Okay, PQ is this little guy right here. Okay. Now look. You see these angles right here and right here. These are called vertical angles because of the way they're formed by an X. Okay? When you have angles that are formed by an X like this, these angles across from each other are called vertical angles. And vertical angles are always equal. So if this is 42 degrees, then this will be 42 degrees. Okay? And arc PQ is the intercepted arc of this 42 degree angle. So by definition, this is a 42 degree arc. Okay, so PQ is 42 degrees. Alright, what's next? Oh, by the way, this little M stands for the measure of. Okay, when you see that M, it means it's asking you for degrees. So, what's the measure of arc TPS? TPS. Okie what dokie. Alright, just getting ready. Alright, TPS is this arc that goes like this. Okay, TP. And I gotta go all the way around to here. Okay, that is arc TPS. And I need to find the measure of that. Well, that's not going to be too hard to do. Let's start with this part of it. Okay. All right. Look at the part that I'm coloring in yellow. Okay. How many degrees is this? The yellow arc that I just highlighted so lavishly. How many degrees is that? All right. I think you will agree that that is 180 degrees. Okay, so like from here to here, that is 180 degrees. Agreed? Alright, semicircle. So, with that in mind, how much extra, alright, because see, remember the pink here is the whole arc that we're trying to do. So how much extra are we adding on by doing this and this? Okay, so we have the yellow part is 180 degrees, plus this extra green part will get us the rest of the pink arc. Okay, so it's 180 degrees plus 64 plus 42. Alright, that is 286 degrees. 64, 42. Okay, what did I say? 286. Alright. So there it is. 286 degrees. I'm a beast. Up, I skipped number 10. I should be going in order. I went from 9 to 11. Alright, number 10. The measure of arc ST. Okay, let's see. Oh, ST is this one little bit here that's left. Okay, so we just calculated that the rest of the circle, everything else, was the previous answer, and that was 286. So if I do, and granted I was supposed to do this first, but same concept. So if I take the whole circle of 360 and subtract the 286, that should leave arc ST. Okay, if this whole pink arc is 286, then this little bit should be the whole circle minus this big old pink arc. Alright, so that is 74 degrees. Okay, so this is 74 degrees. And think about it. If you add all these up, it should make 360. You could check your answers. Alright, in fact, you know that this part over here is a semicircle. Alright, so if I add up 64 and 42 and 74, I should do that. 64 plus 74 plus 42. Oh, look at that, 180 degrees. What do you know? A semicircle. So that's another way of checking your answer. Okay, did I answer the question? 74 degrees. Okay, now number 12. The measure of arc RT. Okay, RT. Alright, RT. Okay, all these colors, let me just take away some of these colors. Okay, obviously this is semicircle, I don't need this to tell me. Alright, RT is this right here. Okay, so that's 74 plus 42. That's 116. Okay, number 13. The measure of arc RQS. Okay, RQS. Okay, it's RQS. Well, RQS is everything except for arc SR. So I should be doing the whole circle is 360. So if I do 360, whoops. If I do 360 minus 42, that should leave the rest. Okay, that should leave arc SR. So that's going to be 318. RQS, just checking. Yep, okay. So number 14, arc QR. Arc QR is a minor arc, of course, and it is the following. Alright, just from Q to R the short way. This is arc QR. Well, I could subtract all of this stuff from 360, alright, because that would do it. But there's a shorter way. If you focus on the fact that what we have here is a semicircle. See how this is the diameter? Okay? So, if you look at this part right here is 42 degrees, alright, this is 42. Then I should be able to go 180 minus 42. And that should leave the yellow QR here. Alright, so that's going to be, so that would be minus 40 would be 140. An extra 2 would be 138. Okay, so that's going to be 138 degrees here. Okay, so yeah, QR. Again, you can check your work. 42 plus 138 should equal 180 because it's a semicircle. Alright, let me just put this in the picture, 138 degrees. Because now I have them all. Okay, they could ask me anything. Okay, the measure of arc PQS. PQS. Okay, so from P to Q to S. Okay, I could add up 42 plus 138 plus 42. Or I could start with 180 and add 42, because I know right from P to R, that's a semicircle, and then it's extra 42. Whatever makes you happy. I'm going to do the 180 plus 42 because that's more efficient. Hold on, I gotta move this a little bit. Okay, so 180 plus the extra 42, 222. Okay, number 16. Alright, the measure of arc TQR. Get rid of this mess. Okay, TQR. So that starts at T and goes through Q and then goes all the way around to R. Well, once again, this is a diameter. Okay, so from here to here is a semicircle. Alright, so far, so from here, from R to P, that's 180. So it's 180 plus an extra 64. $244. Alright, number 17, the measure of arc PS. Okay, now it won't be the long way, it's 2 letters. That means from P to S, the short way would be like this. Alright, so that's just 64 plus 74. 138. Okay. How about the measure of arc PTR? PTR starts at P, goes through T, and comes around to R. So there's arc PTR. Well, look, this is a diameter, which makes this a semicircle, 180 degrees. Okay, that's going to be a convenient place to stop. That was a nice little lesson on arcs and central angles. Okay, to get us started. I'm going to stop this video here. There will be another part to the video, part 2. And in part 2, we're going to do a few more examples dealing with arcs and central angles. I feel a little Pythagorean theorem coming maybe. And let's see, I think we'll do some sketches on the back. So there's more to come in the next video. I'll see you there.